Halogenated derivatives of toluene will undergo hydrolysis via an SN1 process. The rate of hydrolysis is dependent on two main factors: the stability of the leaving group and the stability of the intermediate carbocation. The following are rates of hydrolysis times 10 to the 4th per minute for halogenated derivatives of toluenes at 30 degrees in 50% aqueous acetone. Okay, so this data table you see is the hydrolysis data, the table. Using this data, answer these questions. For A, determine whether chloride or bromide is a better leaving group and explain your choice. Then determine whether the hydrolysis data support your choice. Okay, I can start by describing the strong acid. So for example, I have hydrobromic acid and I have hydrochloric acid. Both are strong acids, but one is stronger. You can displace that H with R, like the case we have, carbons, the hydrocarbons. And imagine that we have the same R, the alkyl structure. Based on the acid and base of these two, hydrobromic acid and the hydrochloric acid, hydrobromic acid is stronger. Its pKa value is much higher, and it has more polarizing effect due to the larger atomic size. So the Br minus, because it's stronger, the conjugate base will be much more stable as opposed to the Cl minus. So because having weak conjugate base is more favorable, we know Br is a much better leaving group. So for now, I will answer Br is a better leaving group, but we have to substantiate our claim here with the hydrolysis data. When we come back to this data, I don't see HHBr. I mean, we could have HHCl versus HHBr, but we are not given such a data, so we can do by having HClCl and HClBr. Okay, for example, I can put the H as our X, Cl as our Y, and then Z is Cl for that correspond with our 2.21, okay, times 10 to the 4th. Everything is 10 to the 4th, so let's just focus on the number itself. So this is 2.21, and then when you substitute the Z with Br, you wanna have the 31 times 1. So looking at that, having Br is a better leaving group, meaning instead of Cl in Z, when we have Br, the hydrolysis data supports that the rate is much faster, meaning it's more favorable. Therefore, this supports our claim that Br is a better leaving group. Okay, faster, so more stabilized to have Br as a leaving group. Okay, that answers our part A.